Hi, in this video we're going to talking about the closed simulation of the Miami. This closed simulation is the PhysX engine based at the close, so the simulation speed should be very fast. So let's first open our example, the sample 36, the origin agent we created before, and with the full setup of the dynamics joint and the bone shape. And let's create a cloak for this guy. Let's create a polygon plan, just like this, a cloak. Let's move this right here. That's it. And let's just add more subdivision here. Please do not add too density of this subdivision. So this kind of things is cool. And then the next thing we're going to do is the bind skin the close, because our system can hold some of the points to this man with the bind skin. So what I'm going to do is pretty much select the free bone, this chest, the shooter, the free bones, and select this close. You can see that we selected the free bones here and this close, and click this animation skin, bind skin, smooth bind. At this time you can see that our origin agent can control this close just like this, and that's it. We can add some of the attach point. If we simulated the close for this cloak, we want some area of this, the points should be attached to this agent. We need to click F8 and switch that to the vertex and select some the close point. And we want these points to be attached on this agent. We need to click the Miami and the PhysX close attach point. You can see that there's the message closed marked OK, and that is cool. And if you want to edit this point, you can select the more points here, because the previously is the free lines of that, and if we want to add more points, we just select the more points here and click this option again, attach point. And there's a question that prompted out, wanted to confirm whether we need to overwrite this setup. We clicked yes, and the fourth line of these points should be added into the attached points of the close, and clicked F8 again, and everything should be fine. Let's place our agents, and we should deplace, and we should select this plan and move that into the geometry group here. That's cool. And you can see that there's a layer. We needed to switch that to the reference mode. Okay, and place our agent. And if you click this reset button, you can see that the close has been created for you, and the run the simulation. Everything is cool. The close is working. And you can see that there are some collide for the close and the body. So we needed to add some of the collision, the bones to this agent. We need to deplace and select some of the bone shape of this, and select this guy, and there the shooter arm. Please select them carefully, and the leg. Okay, and enable the collide close flag here, set that to 1. So at this time, if we placed our agents again and run the simulation, you can see that our close can collide with the body and result the penetration. And for the close, you can add some of the wind to control that. Here, there's an icon for create a wind. And you can see that if we scale that up, you can see that this is the wind direction. Let's just change like this. And there are some of the other values can be controlled. the wind noise and magnitude. Let's make the agent stop. Here, default stand, and just switch that walk to stand. Okay, and let's just test the wind. So this is very useful for simulate something the flags into your scene. Okay, you can see that this wind is working, and we can just add some of the frequency and the frequency noise and the jitter here. Let's just decrease this and make this more natural. 20. You can see that this will work like in the close. You can just use this to simulate a lot of the closes, a lot of flags in your stadium. That should be very fast to simulate, because our engine can simulate the thousands of the flags. Let's do some tests. Select this place node and increase the number. You can see that we can add a lot of them. And distance, come here and place our agents. You can see that this the simulation speed should be okay for simulate 200 closes inside of your scene, and we can adjust the jitter, for example, the 100 for simulating more realistic the closes. You can continue to tweak these values if you like. Let's continue to introduce some extra attribute of the close for you. Let's first open our sample file, the sample 42, the close simulation. And this is a scene which we already built for you with the agent contain a close, and this is the same as the previous the sessions we created, and everything is by default. Let's place our agents and run the simulation. You can see that everything is by default. And in the PhysX global, you can see that there's the agent close session here. You can see that there's a criterion option and something others. Let's just tweak the value and see what will happen. Let's deplace our agents and select the place, set the number of agent to 1, and let's place our agent. Now this is a default value. Let's just increase the damping option here. You can see that the close is more the smooth without any of the jittering, but this is more lighter, and it's very good for simulate some silk or something, a very light close. Let's decrease this down to 0. At this time, you can see that there's a lot of inertia at the close, and you can also increase the bend stiffness. It will act as the rubber, just like a rubber, and I can just increase this down. Now this is a rare use. You can see that, just like the very stick. And the self-collide distance is sometimes you can by default we can make our close collide itself, and if you increase this, this is actually the thickness of the close. You cannot watch this visualize, but this close distance is actually existed. Just decrease this down and run the simulation. You can see that the self-collide should be much better. If you just decrease this down to 0, it will collide, penetrate itself. For example, like this, it will penetrate itself like the edge of the close. You can see that there's something, the self-penetration. If you just increase this up, for example, like 1, it can avoid this the fullness. But if this value is very big, it will cause the problem. So please just keep this, the 0.5, something small value. It will keep everything correct, but also it will not cause any problem. Okay, this is the introduction for the PhysX closed simulation. Thank you for watching. See you next time.